You must have already heard the word microchip so many times. Now it's time to learn how to work with it. What is a microchip? It consists of a whole array of electronic components, transistors, resistors, diodes, etc., all united in one package. We have headers, aka outputs or contacts, coming out of it. Each of them has its own purpose. To understand where to connect the details in a certain microchip, one has to study the manuals, aka the datasheet. As an example, let's take a logic inverter microchip, since it functions in a really simple way and it will simplify your understanding of how to work with a new microchip. In our course, we shall be dealing at least with two microchips, apart from the Atmega controller chip, which is installed in the Arduino board. All microchips look roughly the same. They can have a different number of outputs, but if you take two microchips with the same number of headers, they can be distinguished by their labeling, i.e. the combination of letters and numbers that are written on them and that code their functions. I have entered in the search box of our search engine the inverter's labeling 74HC04 datasheet. We say datasheet, which literally means a sheet with data on it. Thus, I can open one of the suggested variants with the description of this microchip. Let's have another glance at its layout, where all the headers are numbered. One more important thing is how to avoid mixing up all the headers of the microchip. If we work with a DIP package like ours, which has these headers that stick out and perfectly fit in the board, you will see that on one side there is always a notch or a circle like this one. If you place it on top, it will coincide with the depiction of the microchip in the manual. Here, this notch has a circle around it. The pins are numerated starting from the first one in the top left corner counterclockwise. Here, we have a microchip with 14 pins. Therefore, the last 14th output will be in the top right corner. We now need to figure out the labeling that we have written near the headers. Let's scroll the manual down. Here we can read that 1A, the first pin, is the data input. 1Y, the second pin, is the data output, etc. Naturally, every microchip has headers to receive power because microchips perform some actions and they all need power. These are GND ground and MCC power respectively. Now we can compare this list and this picture to figure out where to connect all the components. What does the logic inverter do? It turns the logic 0 into the logic 1, and vice versa, the logic 1 into the logic 0. The 74HC04 microchip has an H6 inverter built in it, and we can see 6 numbered boards, where A is the input and Y is the output, counting from 1, 2, etc. until 6. What will happen if we communicate 0 to the A input? We will receive the logic 1 at the corresponding output, and vice versa. If we communicate 1 at the A input, we shall get 0 value at the output. Thus, if we know what we can achieve with the help of this microchip, we can study its manual, figure out which header to connect to it, and figure out its functions thanks to this small, compact device.